Hello everyone. We are starting a free open lecture on our Discord. If you are a viewer and want to ask questions and get answers online, join our lectures. You can find the link to Discord in our Telegram channel. Now, let's move on to the code itself. Let's take a look at the code. The code seems very cumbersome, but in reality it is very simple. Let's look at the first function. This is the function that we will be calling. It is the merge sorting function for arrays. We have an array, and we call the split function on it. This is our initial action which splits the array. It then returns the merged array. So basically there are two actions. First, split, then merge. Now the question arises, how will it actually split? And so we turn to this. Split the array. So, accordingly, split the array. If the array length is 1, return the array itself. Otherwise, the first half and the second half split the array in half, meaning it also splits it in half and calls the split function itself. This way, as you can see, it calls to return the array up to the middle and the array from the middle to the end. It just takes two halves regularly and splits. There will be logarithmic splits. This is exactly what is written here. The next function we call is to merge. It calls the array, and what it does is we get the final array, which will initially be empty. If the array is odd, add an empty array. We add an additional array to throw in one of the elements for evenness. It's just that when we have an array, for example, with a single element, it can't just remain as a single element. We need to ensure that there is an empty one. In any case, if an array, for example, of one element is combined with an empty array, it will result in an array of one element. This is done to ensure there is an even number, making it easier for us to handle. Accordingly, it calls the array to add an empty array from 0 to the length of the array minus 1 in steps of 2 because it pairs the elements, and it sorts these arrays. The final array adds the current one. So, the question now is how it sorts. Here it is said to sort the array. It sorts using the algorithm we discussed. We have the first array and the second array, which come from the arrays I and j equal to 0 and the new array initially empty. We will be adding values to the new array. While the length of I is less than the length of the first array, and j is less than the length of the second array, if the first array with index I, that is the 0 element of the first array, is less than the first element of the second array, yes, that is under the j index. In this case, we just add the first element from the first array to the new array, and then move it. Otherwise, we add the new element to the second array, also j, and j is incremented by 1. Accordingly, we have covered this part, and these are the two tails exactly. These are two tails. And when we are left with one of the tails, we simply start adding these elements to the new array. 830 because 8 is less than 30, so we sort them in ascending order. 0, 24, 5, 3, 6, and one single one. The single one doesn't have a pair, so it remains separate. At some point, it will join with someone.
Want to become a great programmer? Subscribe to our Telegram channel.
Next, we move to 830, 0, 20. We also merge them and get 0, 8, 20, 30. They are sorted and we get the list 0, 8, 20, 30. Here we get 3, 4, 5, and 6 because we had 3, 6, and 4, 5. So we get 3, 4, 5, and 6, 456 because we had 3,645, so 3,456. So we will have the first elements, does not always work, and then the second elements will be 5 and 6. This is the case here. We might have a situation where, for example, there will be 4 and 5 in one list, and here there will be 20 and 30, for instance. So, accordingly, these two elements will go first, and then these two. We will also look at the algorithm and how it sorts these two lists. Accordingly, now we are merging these two lists. Yes, the one doesn't have a pair again because it stands alone. An odd number will constantly be formed here. 0, then comes 3, 4, 5, and 6, then comes 8, 20, 30. That is, we have already reached the end of this array, and there is some tail left here, and we simply copy this tail because all the elements in this tail are greater than the last element in the second list. Accordingly, in the fourth pass, we merge our complete list from the previous step with the last single element. Now, the single element has found its pair, forming the largest array. We proceed in the same way, comparing 0 and 1, and since this list is now finished, everything remaining in the tail will be greater than the single element. Therefore, we overwrite everything here, and as a result of this sorting, we get the following list: 0, 1, 3, 4, 5, 6, 8, 20, and 30. This list is now sorted. Now let's move on and examine how it sorts these two elements with each other. For example, 8, 30, and 0, 20. I took this from the example, so let's figure it out. He sorts using the two-pointer method or the merge method through the two-pointer method. It is called this in algorithmic programming, so we will commonly use it in algorithmic programming. Also, we set two pointers. These are I and pointer j. The first is set at the beginning of the first array, and the second is set at the beginning of the second array, and it compares which element is greater or smaller. In this case, we will compare the first elements. For example, if the first element I is greater than the first element j, it is accordingly rewritten into the list. The one that is smaller, because it is sorting in ascending order, the smaller one will be rewritten. Accordingly, is 8 greater than 0? No. Are they equal? No. In this case, we put 0 into the result, and move j to the right. Now we compare 8 and 20, that is, we compare by pointer I and by pointer j. 8 is not greater than 20, they are not equal, so this one is smaller. We just add 8 and move on. Now 30 and 20. 30 is greater than 20, so we will overwrite 20, and our j has gone beyond the array, which is now slightly out of bounds, and needs to be handled carefully. In this case, we are left with what is called a tail. Everything that remains here, as I mentioned there, we are left with a tail. And we obviously understand that this entire tail will be greater than 20, because if this element turned out to be smaller, it would have been excluded. Accordingly, everything in the tail turned out to be greater than 20. Therefore, we copy this entire tail to the end and add it to the result. Thus, the result of this sorting, or more precisely this merging, is that the array becomes sorted using this algorithm, and we get the result 0, 8, 20, 30. We perform each step, that is, each merging of two lists, using this algorithm, and with each of them, we get our sorted array as the result. That's how it works. What is the complexity of this sorting? This sorting has the complexity of the length of this array, plus the complexity of the length of that array. That is, they are linear, so the complexity of this is linear, not logarithmic. Thus, each step here has a length of on, because we will be merging arrays, and in total their length is on. This plus this, and this just remains, so the length is on. We have logarithmic steps, because they pair up each time, forming logarithmic pairs of connections. Therefore, the complexity of this algorithm is essentially n log n base 2, and the worst case complexity is also essentially n log n base 2. Thus, the merging follows essentially n log n base 2, and the splitting, which we didn't explain here but is essentially the reverse of this, will also be essentially n log n base 2, as it will split them in the same way.
Want to become a great programmer? Subscribe to our Telegram channel.